Hopefully by the end of this video, you will feel more comfortable solving logarithmic equations. So we're going to take two approaches to solving these. The first few that we'll do involve equations with one logarithm. The second few that we'll do involve equations with two logarithms. So you'll see log appearing twice. Two different methods should be used. So in the first one, when you only have one log in your equation, you want to get the log by itself on one side of the equal sign. So you want to isolate the logarithmic expression and then rewrite your logarithmic equation in exponential form and solve that equation. So if I look at number 1, you can see that I have log base 8 of 64. So this entire left side is my logarithmic expression, and that's all that's over there. So in this case, my logarithmic expression is isolated. It's by itself on the left. And so I'm good to now rewrite this in exponential form. So first, identify the base. So the base is 8. So it's going to be 8 raised to the power y is equal to 64. And now I just want to solve. So when I'm solving exponential equations, one of my methods was trying to make the bases be the same. And if you know that 8 times 8 is 64, well, that's what you can do here. So 64 is 8 squared. So I can write 8 to the y power is equal to 8 squared. Since the bases are the same, I can write the equation of the exponent, so y equals 2. And that's my solution. Number 2, the left-hand side is all logarithm. So it's log base 3 of this expression. So since the logarithm is by itself on the left-hand side, I'm good to go ahead and rewrite it in exponential form. So first, identify the base. So the base is 3. You're going to raise it to the power of 3 because you go across the equal sign. And then set it equal to the argument, or what you're taking the log of. So m squared minus 2m plus 3. Now notice that you have a quadratic equation. So you're going to solve this like you would a quadratic. Normally when you solve a quadratic equation, your goal is to get everything on the same side of the equal sign and set it equal to 0 so that you can either try to factor or use the quadratic formula. So I'm going to do that. So the left-hand side, 3 cubed, 3 times 3 is 9, times 3 is 27. Bring everything down on the right. I then want to move the 27 over, so I'm going to subtract 27 from both sides. So I'm going to get m squared minus 2m minus 24 is equal to 0. Now that my quadratic is set equal to 0, I'm going to try to factor. So m squared, m times m is m squared. Since the number 24 is negative, that means my signs are going to be different. So I'm going to have 1 plus 1 minus. What multiplies to get 24 and subtracts to get 4, that's going to be 6 and 4. And since my 2 is negative, my larger number is going to be negative. So 4 times negative 6 is negative 24. 4 plus negative 6 is negative 2, so that works. Now you can set each factor equal to 0 separately and solve. And so when you subtract 4, you get negative 4. And when you add 6, you get 6. So your two possible answers are negative 4 and 6. It's really important that you remember when you start with a logarithmic equation, you have to check your answers to see if they work. Really, you don't have to check the entire thing. You don't have to check to see if it is equivalent. All you have to do is check to make sure the argument is positive. So whatever you're taking the log of, in this case it's this, that has to be positive. It cannot be 0 and it cannot be negative. That doesn't mean your answer can't be negative. It means that the entire argument cannot be negative. So first I'm going to check, not x, m is equal to negative 4. All I'm going to do is plug negative 4 into the argument. So negative 4 squared is positive 16. Negative 2 times negative 4 is positive 8. And I don't even care what the number is. I can see that if I'm adding all positives, the answer is going to be positive. So that means negative 4 is a solution. Notice the 4 is negative, and that's fine. My answer can be negative. The argument cannot be negative. Now I want to check 6. So I'm going to plug 6 into the argument. I want to make sure that it's going to be positive. So 6 squared is 36. Negative 2 times 6 is 12, so minus 12 plus 3. 36 minus 12 is 24. 24 plus 3 is positive 27, so that also is positive. So 6 is also a valid solution. So there are two answers to this equation, negative 4 and 6. Number 3, I have one log in my equation. So then I want to check to make sure it's by itself on one side of the equal sign. That 5 in the front, that coefficient, is going to mess it up for us. This is 5 times the log base 7 of n. So I want to undo that 5 by dividing. That will give me the log base 7 of n is equal to 2. And now my log is by itself on the left-hand side. So I identify my base, and I rewrite it in exponential form. So 7 raised to the second power is equal to n. And so that's actually very simple, right? 49 is n. I want to make sure I check my argument at the top is n. If I plug 49 in, 49 is positive, so that is a valid solution. Okay, number 4. You can see that we have one log, so we're going to use the same process, getting that log by itself and then rewriting in exponential form. So let's just kind of highlight the log of 8n plus 4. So what I just highlighted in red is what I want to get by itself before I can write it in exponential form. So I need to get rid of that 2, and I need to get rid of the 6. So you undo addition and subtraction first. So I'm going to start by subtracting 6 from both sides. So that'll give me 2 times the log of 8n plus 4 is equal to 4. And now I'm going to undo that multiplication by 2 by dividing. So that's going to give me log of 8n plus 4 is equal to 2. Now that I have the log by itself on the left, I am going to rewrite it in exponential form. So my base, there's no base written, that means it's understood to be a 10. So it's going to be 10 squared is equal to 8n plus 4. And now I want to solve for n. So I will have 100 equals 8n plus 4 minus 4 from both sides. So I get 96 is equal to 8n. Divide by 8. You get n is equal to 12. Again, you want to check. So I'm going to check by plugging it in just the argument. So the argument is 8n plus 4. Well, it's all positive. So the answer is definitely going to be positive. So 12 is a valid solution to this equation. Okay, let's look at some more. So here we have 3 more examples. Notice that in each of these examples, we have more than one log. The good news is, if you only have 2 logs in your equation, one on each side, and there's nothing added or subtracted outside the parentheses, so it's just a logarithmic expression equals a logarithmic expression, those just undo each other. The logs undo each other. So in the case of number 5, You have a natural log on both sides, so those undo each other, and the arguments can be set equal to one another. So 10 minus 3x equals negative 4x. If you solve that equation, you will find the answers to your original equation. So we want to get the x's on one side of the equal sign. So we'll get 10 equals negative x. Divide by negative 1. So x equals negative 10. Again, we started with a log, so we need to check. So we're going to check x equals negative 10. Notice that this time I have two arguments to check because I have two logs. So I have to check both of them. So my first one is 10 minus 3 times negative 10. So that's going to be 10 plus 30. Well, that's going to be positive, so that checks. My second argument is negative 4 times x, so that's negative 4 times negative 10. That's going to be a positive 40, so that checks. So since both of the arguments will be positive, if I plug in this negative 10 is a valid solution. Number 6, notice I have one log on each side. They're both log base 13, so the bases do need to match. If I had, like, let's say log 4 on this side, I couldn't just cancel out the logs because it's not the same operation. They have to be the same base to make it be the same operation, so they undo each other. So log base 13 is the same. So I can create an equation where I just set the arguments equal to each other. So 5n minus 2 equals 8 minus 5n. And then I'm going to solve that simple linear equation. So bring all my n's to one side. So I can add 5n to both sides. Add 2 to both sides. So bring my constants to the right. And I will get 10n is equal to 10. And then I finish by dividing by 10. So n equals 1. Don't forget that you want to check. It's really easy to forget that step. So you really have to check when you have logarithmic equations. So I have two arguments this time, and I need to check in both. So my first argument, I have 5n, so 5 times 1 minus 2. Well, that's going to be 5 minus 2, which is 3, which is positive, so good. My second argument is 8 minus 5n, so 8 minus 5 times 1. That's 8 minus 5, which is 3, so it checks. So 1 is the answer to that equation. So in a way, these are easier, right? If you have two logarithms, one on each side, it's kind of easier because all you have to do is cancel them out. All right, number 7, you can see that I have the common log on both sides. Since they match, I can cross those out. And I will have 2x squared minus 14x is equal to negative 45 plus x squared. You can see that I'm going to have a quadratic equation because I have x squares. So I want to move all those to the same side of the equal sign so that I can then factor or use quadratic formula. So I'm going to subtract x squared from both sides and add 45 to both sides, and that will give me a 0 on the right. So 2x squared minus x squared is x squared. Then I have the minus 14x, and then the plus 45 equals 0. I'm going to try to factor this. So I'll have x. Since the sign back here is positive, that means both of my signs are going to be the same. And since that sign is negative, they'll both be minus. What multiplies to 45 and adds to 14? 9 times 5. So there are my factors. And then I can set each factor equal to 0 and solve. So I will get x equals 9 and x equals 5. And so I need to check both of these in both of the arguments. So first I'm going to check x equals 9. So my first argument is 2x squared, so 2 times 9 squared minus 14 times 9. So 9 squared is 81, times 2 is 162, 14 times 9 is 126, and that's going to be positive. If you want to know the number, it's 36, so that checks. Now I'm going to check, I'm going to move this up slightly. Now I'm going to check the second argument, still for 9. So that's going to be, let's see, negative 45 plus 9 squared. So that's going to be negative 45 plus 81, and that's also going to be positive. So that's going to be 36, so that checks. So x equals 9 is a solution. And now I'm going to do the same thing with 5. So I'm going to check x equals 5. So in my first argument, I've got 2 times 5 squared minus 14 times 5. So 5 squared is 25, times 2 is 50. 14 times 5 is 70. 50 minus 70 is negative 20. Okay, finally I got one that did not check, right? Do you see how this is a negative? That means I'm going to be trying to take the log of a negative 20, and that's not okay. You can't take the log of a negative number. So 5 does not check. I don't even have to check the second argument, because if it doesn't check in the first, it doesn't matter. So the only solution to this equation is 9.